Okay, so 2a said, hey, give me a negative angle. Remember, I want this dot. I can't go from this dot. Okay, negative angle and a positive radius. That will also be right here. So how do I get to this location?
Negative pi over 4.
Yeah, can I go from here to here?
Yeah.
Totally. And if I want a positive radius, the dots have to be right on the ray, right? If it's a negative radius, then it'll be the
Other way.
Okay, so the final answer is, what should we write for the final answer? 5, comma, negative pi over 4. Great. Okay. Now 2i says, I want now negative radius. I want the angle to be what? Positive. Remember, I want it the same dot. I can't move my dot. Alright? Here is my angle. I want it to be here still. So how do I get a positive angle and a negative radius would still be here?
Negative 5 over 4. 3 pi over 4. 3 pi.
Remember, to get this as a negative radius, I had to end over here, right?
Yes.
Ah. So what angle is that? 3 pi over 4, right? Is the angle. Okay. So the angle is 3 pi over 4. And I want a negative radius, so it's negative 5. So let's check it. Here is 3 pi over 4. It's right there. Is that okay? I can't be there because I want to be a negative 5 radius. So that's the ray that I ended, but I can't have it. I have to go the other side, right? And the other side is going to be at negative 5, so that checks out. Okay? All right. 3 eyes. I want a positive radius, and I want theta to be over 1 revolution. How do you get there? Can I do that at 2 pi? Yeah, because isn't this radius already positive? Yes. So what's your final answer? 5 comma 15 pi over 4. Good. Okay. Questions, comments? Okay, so B last night graphed it out, negative pi over 6. I don't have a graph because I erased them. Okay, negative pi over 6 this way. And they want a positive 3 radius. So it happens to be on the same 1, 2, 3. Okay, so is that the dot, by the way? Negative pi over 6. All right, 2, 1i. Ready? Radius is positive. I want the angle to be negative. Does it meet the requirement? Yes, I can just copy it down. I don't have to change. Okay. So that answer is just 3 comma negative pi over 6. Now 2i says I want radius now to be negative, angle to be positive. Does it meet my requirement? No. So let's go back to my drawing. I want a positive, what? Radius. I'm sorry, positive angle. Yep, negative. How do I get there? So 5 pi over 6. Are you trying to tell me that I'm going to go right here?
Yeah.
Okay, that's 5 pi over 6. And then negative 3. Perfect. Okay. So negative 3, 5 pi over 6. Okay. Okay, next one. I want R to be positive and theta to be over a full positive revolution. So, what are you going to do? Is R already positive?
No.
Yes.
Yeah,
Okay. So, remember, theta now needs to be a revolution over a revolution. Okay. So the first thing is, can I start here and go here? No. That's less than, right?
Yeah.
Can I add another revolution though?
Yeah.
Yes. So I can take the positive angle. So what was the first time around? 11 pi over 6. Plus a full revolution. Oh, dang it. It went to sleep. Okay. So 11 pi over 6 plus 2 pi. So that's 12 over 6. So what's the final answer? All right. Write that down as I correct our All right, guys. So we decided what is the fine answer here? Beautiful. All right, C and D. I want you and your team. Try it out. I'm going to put, what, 5 minutes on the clock? I'm going to walk around to see if you guys are on track. What?
If it was negative 2 pi, it would be pi.
Oh, that's second.
So if you had pi positive 2, right? So
I or 2.
Oh, wait.
Same thing. Wouldn't that be like 2 comma 2 pi?
No, is it 2 comma negative pi? It should be negative. So.
Oh, negative pi. Yeah.
So then
Wait, but that
this
would-
one has to be
Oh, never mind.
this one has to be negative. So then that's already right.
Wouldn't that be?
You can use this
So
one the
would it
same.
be 2 comma negative pi?
Yeah. For first one.
Yeah. Oh, yeah. You guys are ahead. Okay.
2 is fine. 0 is okay, right? Yeah, because it's bar. Okay, so 3i, it has to be positive, so it'd be 2. And then that would be negative pi, so you have to add another pi. So that'll be 0, and then add 2 pi. 2 pi. That sounds right. It's like it's simply as
Wait,
this.
which one? Oh, you guys. Okay.
Negative pi, and then you add 2. Yeah. Really?
Oh, you can just keep it at 0. Okay.
Okay. And then for D, it's to be greater than.
Wait.
Wait for Ryan.
Would it be 3 pi?
So you add
Oh,
a
it
pi
can
to
be
make it positive, and then there's a
Okay. And then.
I didn't start early. 6.
Okay. So 6 comma.
what are you stressing about?
This one you can keep the same.
Yes.
Correct.
I don't even know what you're asking.
One of them
Negative pi over 3.
Yeah.
And then keep the
You
same
have a
for
bunch of
D.
dots to put
Yes.
together to make maybe like a heart. You know?
Are we doing that thing?
Maybe.
If we do, can I try writing on it? 'Cause I remember it.
6, so it'd be negative.
we don't D.
No.
Wait, no. Wait, what? Actually, never mind. I don't want to write on it.
2 pi over 3 plus 6 pi over 3 is 8 pi over 3.
What?
Like it's the same value.
Oh.
Because it's negative 6
Yeah,
pi
'cause 6
3.
pi
You have
over
to
3.
do the opposite angle, so that'd be 6 common. Oh, wait, no, just kidding.
That's 7 pi over 3.
Yeah.
All right. I'm in your team now, since Olivia taking a test. All right, Jacqueline.
Oh, she's taking a test?
What do you have for C? Shh. Jacqueline speaks. Yeah, first one. 2. Ooh. Shh. Jacqueline said the answer, final answer is 2 negative pi. Is she right?
Yes. She did it so easy.
Yes. Okay, here we go. Shh. Brandon N.
Oh, whoa. Negative 2, 0.
Negative 2, 0, Brandon said. For 2 double I. Good. Moving on. Christina. 3 triple I's. Let us see. Yeah. 2 comma what? 3 pi? Is Christina right?
What?
C.
Oh, we got 2.
Now, okay, so if you got that one wrong, remember we want it to be over revolution, right?
Oh, yeah.
Okay, so you have to, the first arrow to get to that point, which is a pi, and then you have to add another 2 pi.
We added it with.
Okay.
Oh.
All right, D for dog.
Like we thought we added the final answer after.
All right, Megan. What do you get?
No.
I said 3 pi to begin with.
Yeah. Okay, we get it. You're smart.
Six negative. I'm sorry. One more time. 2 pi over 3. Is Megan right?
Yes. Yes.
No.
Yes.
Yes.
Yes. Yes.
Okay. Well, let's look at it. Haha. Okay. Shh. We want a negative angle, right? Macy's pump. Okay. A negative angle. Shh, guys, I don't want to shush you. Okay, a negative angle means I'm just going to go this way. Is that okay? So from there to there is exactly negative 2 pi over 3. Okay. It wants a positive radius. Am I correct? Because it's a positive radius, can I draw my 6 units right on the same ray? Okay, and that is correct. Okay. All right. Kayla, how about 2 eyes? Negative radius and a positive angle. Negative 6 and then what? Pi over 3. Is Kayla right?
Yes.
Yeah, so this is how we can see it, okay? Well, pi over 3 is right here, okay? And a negative radius, it means I have to go the other direction to plot my dot, so perfect. Last one. Wilson.
Oh. 6, 10 pi over 3.
10 pi over 3.
Wrong.
Wrong?
What? No. No.
Okay. It's not wrong. Okay.
Okay, something's going on with that.
All right, let's
Yeah.
work this out. Ready? We want positive radius. Okay. From here to here. Let's pay attention. What is that angle? How big is that angle?
7 or
From here to here. 4 pi over 3, right, class?
yeah.
Because it's a positive radius, I can just mark my 6 on the same ray. But remember, the restriction is the second revolution. So couldn't I just take this and add 2 pi? Yes, so that's how we come up with 10 pi over 3. Okay, and,
Oh.
okay. What piece? Are you okay?
I get 10 pi over 3.
Well, okay, are you okay with, what is the restriction for 3 eyes?
It has to be greater than 0 for the radius and over a revolution.
Right, okay, so remember, D was this dot. See this dot right here? Right? Okay, I want that dot. Okay, so from the polar axis to here, how big was that?
3.
Something.
So how big was that?
7?
Remember, this is a pi, right?
Mm.
This angle, we drew it out earlier in the notes, that was pi over 3. So what was this angle? So if this is pi over
4 pi
3.
over 3?
Okay, so from here, here's 4 pi over 3. Are you okay with that? Does that meet my restriction of over revolution?
No.
No. So guess what? I have to keep on going, right? So I'm going to go, right, full 1 revolution, and then another
Oh, okay.
4 pi over 3. So I'm adding a 2 pi. Well, 2 pi with denominator of 3 is kind of like what?
6 pi over 3.
Right? Okay, so that's how we
Oh,
end up with
okay,
10 pi over 3. Awesome.
I need to draw that out.
Yes, make a picture.
I was thinking pi over 6, I was like 7.
So,
Yeah.
when do you know when to add pi over 3 or from 2 pi over 3? 'Cause I mean from 4 pi over 3. I added pi over 3 instead of 2 pi over 3. Or I mean, I added 2 pi, but I used pi over 3 plus 2 pi now.
No, but pi over 3, it's a negative 6. right? Radius. For your restriction on this, it wants a positive radius. So if you put a pi over 3, a positive radius means your dot is over here, and that's incorrect, right? So you have to go from here all the way to here. Because the radius is positive, meaning that you're drawing your dot on the ray. Okay. All right, let's fill this out. We will fill this out before example 3, and guess what? We're on example 3. Okay. Conversion. Conversion from polar coordinates to rectangular coordinates. Theorem. Okay. If P is a point with polar coordinates r comma theta, the rectangular coordinates, by the way, what on earth is the rectangular coordinate?
That's the regular curvature.
Yeah, the only one that we have been using, okay? The rectangular coordinates x comma y of P are given by. So here's P. Can you see P right there? I'm gonna make a right triangle. Okay. What do we call this right triangle? What is that base? X. Okay. What is this height? Y. Okay. Now in baby geometry, yes, baby geometry. Here we go. Cosine of theta is always opposite over hypotenuse. So what's opposite? What's hypotenuse? I'm sorry. Ooh, cosine. Cosine is adjacent over hypotenuse. Ooh. So what's adjacent? X over R. Okay. Wow. Now, I want to solve for X. So how do you solve for X? Multiply both sides by R. So guess what? X is always R times cosine of theta. And that's where this first line is going to get. Okay. One of my physics students said, you should have taught us this last time or last week because you guys had the physics test yesterday or quiz.
Yeah.
There you go.
That was so hard.
All right, that was just X. Well, similarly, I can use baby trick to do sine. Sine is always opposite now over hypotenuse. Okay, solve for Y by dividing or multiplying both sides by R. So this is why physics uses math, right? All right, so the other line gets Y equals R times sine of theta. So this is how we solve for X, and this is how we solve for Y. Now, what if I want to go reversal order? I give you rectangular, and you have to find R and theta. In Pythagoras, he said, a squared plus b squared equals c squared. In this triangle, I don't have ABC label. What do I have? X squared plus y squared equals r squared. Look, I knew we would be very tired today. I even typed the square out for you. Okay. So that means r is the square root of x squared plus y squared. Now someone said, hey, when you're solving for r, shouldn't you have plus and minus? Yes, that's true. But the plus and minus depends on the quadrant in this case. So that's why I'm not spelling that out, okay? Now tangent, baby geometry. Tangent of an angle is always opposite over adjacent. Okay, so in this case, y divided by x. So how do we solve for theta? Tangent inverse of y divided by x. Okay. Now we're borrowing, okay? We're borrowing tangent inverse to solve. Tangent inverse is restricted in quad 1 and 4. So whatever it is, it will only give you answers in quad 1 and 4. Since this dot is in quad 1, this is totally okay. Is that understood? Now, but what happens when the dot, so let me write in quad 1, in Q1. What happens when the dot is not in quad 1, like this dot? Okay. The box below. This dot is in quadrant number 2. Okay. So, well, let's fill in the blank right there. What equals square root of x squared plus y squared again? R. Okay. Now, to get theta, we're still going to do tangent equals the opposite over adjacent, which is y divided by x. I'm in quad 2. My original function is regular tangent. I can be anywhere. Okay. This dot in quad 2. in quad 2, is tangent positive or negative?
Negative.
Great. But when you punch in your calculator, the calculator will give you an answer in quad?
1.
Where?
1.
4. I don't want 4. My dot's in 2. How do I bring it back to quad 2? Add a pi. Okay. All right. Add a pi. So this is for dot in quadrant number 2. Okay. All right. What if the dot's not in quad 2? It's in quad 3. So here's the dot in quad 3. Again, what equals square root x squared plus y squared?
R.
R. Okay. This is how we find polar. Tangent again is y divided by x. So theta equals tangent inverse of y divided by x. I'm in quad 3. Your calculator would not ever give you an answer in quad 3. In quad 3, is tangent positive or negative?
Positive.
So your calculator will immediately spit out an answer in quad 1. But I want something in quad 3. Add a pi. Okay. Okay. How about you have a dot in quad 4? Do I have to worry? No, because tangent will totally give you something in quad 4. That's not a big deal. Okay, so what's different in quad 2 and quad 3?
Add a pi.
Add a pi. Okay. All right. Now, let's go solve example 3. The polar coordinates from example 1. Oh, I know. It's to use those 4 points again in example 1. Find the rectangular coordinates of each point. Okay. So, Dylan, can you give me the point from A from example 1? Oh, sorry. Dylan L. So this one. Thank you. Okay, this is polar. Our job is to take this polar and convert it to rectangular. That means I want what x is and y is, right? How do we find x and y? X is always r times cosine of theta. Okay. So x equals r is 5. Antoine, what's theta? Great. Beautiful. Okay. You still have to know trick. Okay. So Alex, what is cosine of 7 pi over 4? Oh, you missed something?
135.
No. That's in quad 4, right, y'all? Cosine quad 4 is positive. Okay. Oh, I love you. All right. Is that okay? Yes, okay. Y is always r sine of theta. Okay. Y is r is 5, sine of theta is 7 pi over 4. Macy, what's sine of 7 pi over 4?
Negative reciprocal.
Beautiful. So this is going to be negative 5 rad 2 all over 2. So I need an order pair for rectangular. Paul, what's your order final answer pair? Beautiful. Good job. Okay, so that's your rectangular. Okay. I'm going to wait so you can copy it down. Questions? Now, if I were to go back to example 1, do you guys remember the dot was in quadrant number 4? So if the dot's in quad 4, is x positive or negative? Positive. Is y positive or negative? Negative. Did we get what we wanted to get? Yes. And that's exactly what's supposed to be. Okay. B. Mia, can you give me B from what was the dot from example 1b? 3, comma, negative pi over 6. Beautiful. All right, let's find x. Here we go. X equals what? Frankie, but he left. Okay, so Caitlin, Caitlin T, what is x equals to?
R cosine theta.
Beautiful. Okay, so let's fill it out. R, x equals 3 times cosine of a negative pi over 6. Okay. Natalie, what is cosine of a negative pi over 6?
Grad 3 over 2.
Do you guys agree?
Yeah.
Because isn't quad 4, that's still positive. Okay, so this is 3 rad 3 all over 2. So y equals 3 times sine of a negative pi over 6, okay, which is 3 times, what is sine, Kylie, of a negative pi over 6? Beautiful. Okay. So this is a negative 3 over 2. So my order pair is 3 rad 3 divided by 2, comma, negative 3 over 2. Okay. All right, you have D and C. Let's go. I'm sorry, what am I saying? C and D, in that order. C was negative 2 comma 0, right? So let's look at the graph really quickly, okay? Which I did not graph because I erased it. Here we go. So that was angle 0 because his radius negative. I'm going back here, so there's my dot, okay? So here's the dot for C. This is in polar. By looking at it, what do you think? What would be rectangular coordinate? Same thing, right?
Yeah.
Maybe?
Yeah.
Is it the same?
It is the same.
Yeah, same.
Actually,
Is x negative 2? Is y 0?
Yes.
Yes. And if you don't believe it, you can totally plug it in the equation and still get the same thing. So sometimes polar and rectangular can have the same exact value. Okay. Oh, I know. All right, I'm going to leave D for you to try on your own. All right, D was that point of negative 6 comma pi over 3. And you and your team, work it out. I'm going to shuffle your cards so that way. Once you have an answer, can you compare them with your peeps?
I forgot what I was doing. Negative 3 comma negative 3.
I went to Mrs. Hoffman and saw some unhealthy snacks. Someone said so.
Why would you ever do that? Stealing is bad. That is what it is. Oh yeah.
I did. I know all the mistakes that I've done.
Yeah, I could have totally done that one.
You know, a day late.
A day late and $1 short.
Well, no, I have it next period, so it would have been like super fresh.
This would have made more sense, right?
Well, it's the same thing except this is in radians and that's in degrees. So I'm like, you add the day, you add pi.
There's some stuff that
So like I go there and I like calculate radians and like switch to degrees and forget. Yeah.
So it's yeah, but the thing is, like, if I'm not asking questions in class, then I feel like it'd be okay with video. But then sometimes I do have questions, then it would not be okay.
All right, Solani, final answer. Final answer to D. Shh, negative 3 comma what? All right, is this right?
Yeah.
Yes.
Gorgeous. Example quattro. The rectangular coordinates of a point are given to us. Okay. Find the polar coordinates of each. Let's read the steps first. Steps for converting from rectangular to polar coordinates. Ryan, help me read step 1, please.
Always plot the point xy first, as we did in examples 5 and 6.
Okay, well, we did not do example 5 and 6 yet, so cross that out. And then we're going to cross out C figure 15. I did not give you a figure. We're going to draw it yourself, okay? Mile, can you help me reset 2, please?
Which step 2?
Yes.
So if x equals 0 or y equals 0, use your illustration to find the radius of theta.
Very good. Dylan D, help me reset 3, please.
If x is not equal to 0 and y is not equal to 0, then r equals radical x squared plus y squared.
Awesome. Randall, step 4.
To find theta, first determine the quadrant in which the point lies.
Beautiful.
That should be the other step 2.
No. Quad 1 and 4. How do we find theta?
Tangent inverse of y is f of y over x.
But when it's in 2 and 3, you have to add a pi. That's right. Okay, let's work this out. It said to draw a figure, so let's draw it out. Okay, here's a rectangular point. Okay, this is now old school. This is like algebra 1. How do I plot a point in algebra 1? Up 4. 1, 2. How do you move 0?
You don't.
All right, up 4. Here's your algebra 1 dot. Okay. You remember in algebra 1 we plot a lot of dots and like make shapes and whatnot? See, exactly. Okay.
Can we do that?
We would do that in polar.
I like that. Really? You make it?
Like that, see? Alright. Sometimes plotting a dot is enough, right? Is it possible for us to get the radius and an angle from just this graph?
Yes.
What angle would you like to use today? Positive angle or negative angle?
Negative.
What?
Positive.
Doesn't matter. Okay, what angle is that? Pi over 2.
Oh.
What's the radius?
4.
4, because you go up 4 units, so the radius is 4, or r is 4. Yes, you can totally have negative angle. So Dylan, write whatever you want to write, okay? All right, B, plot the dots. Positive 1, 2, 3, negative 3, 1, 2, 3. You are in what quadrant? The 4th, okay? So now you have to decide. How do we find theta? Theta is always tangent inverse of y divided by. Do I have to add a pi? Nope, I'm in quad 4. Okay, so what is y and what's x in here? Harold, what's y and what's x?
Y is negative 3 and x is 3.
Beautiful. Can I simplify that, class? That's really tangent inverse of a negative 1, which is, we all should know this. What's the answer? Correct. Or? Yes, which one do you want to use today?
Negative pi over 4.
Yeah, because that's just the, you don't have to, because the original was just a dot. We don't know whether they want positive or negative, so you can use this one. Okay. I have theta. Is it possible to find r?
Yes.
How do you find r? X squared plus y squared. Okay, so 3 squared is 9. Negative 3 squared is also 9. Can I leave it as a square root of 18?
No.
No. That's what?
3 red
2.
All right.
2.
Final solution. 3 rad 2, comma, negative pi over 4. All right, you and your team. Peeps, work out C.
That's not it.
I'm asking for intercepts. Find the intercepts.
No, I'm just putting it somewhere between negative 1 and negative 2. Because the actual graph doesn't really matter. You know, it's just so you know what. Yeah. Yeah.
And then you gotta add 5 or 4 pi over here.
4 pi over
That could be pi over
180, but you do pi. Pi.
2 comma 4 pi. The thing for me is I'm gonna forget to do plus pi.
I had heard somebody say it. Like,
Hi, Megan, you're the winner of C. What did you end up with? Final answer. Okay, we'll wait for Megan. Miles. Oh, you're gonna give Megan a break and give me the answer?
Yeah.
Okay. Let's give it to me. I'm sorry, I can't hear you. What? No? What?
And he volunteered it too.
I love. All right. Okay, should I plot it out just to see what quadrant?
no.
It's in the third.
Right over equals test yesterday.
Wait.
It's because he got the tangent of pi over
I said 3.
Tangent inverse of negative rad 3 divided by negative 1. Y'all, it's in quad 3. Do you have to add?
Yes.
Okay. Shh. We still expect you to know, bless you,
Thank you.
the exact value of tangent inverse of radical 3, which is what?
Pi over 3.
So this should have been 4 pi over.
3.
Great. Okay. R equals square root x squared. 1 square is always 1, right?
Yes.
Radical 3 squared is always 3. So this is 2. So final answer is 2 comma 4 pi over 3. All right, last example of today. Caitlin D, can you help me read the direction, please?
The letter x and y represent rectangular coordinates. Write each equation using polar coordinates r and theta. Yeah.
All right. So we are currently in rectangular equation. You are to rewrite them all using only r and theta. So let's remind ourselves. R squared is always great, beautiful. Okay. Square root of x squared plus y squared is always r. Right? What is x equals to? R cosine of some angle, theta. What is y equals to?
R sine theta.
Great. Yeah. Bless you. Okay, so those are the things that you have to know. And no, I would never give it to you. Every identity in this class you need to know. So, we have 4x squared plus 4y squared equals x. Is it possible to convert one of them right away? Which one can you convert? X. What is x always?
R.
R. cosine of theta, right? So this is r cosine of theta. Now,
No.
if you divide 4, the 4 is going to be on this side. It's going to get uglier.
R cosine theta.
I don't want to divide by 4. He's on the right. I do want to factor out a 4. Okay.
Oh, and then that's an identity, and that's r squared.
Okay. Factoring out a 4 will not change my equation, but it makes it prettier, right? What's x squared plus y squared? R squared.
This would have been so helpful yesterday.
All right, so that's my final answer. Now, just a heads up. Now, your book sometimes might move it, okay? So that way it once equals to 0. So keep in mind the equivalency. Sometimes it goes kind of funky and factor out things as well, okay? So keep in mind all of these are just equivalency of the original. I will accept any one of those. Is that understood? All right, B, last letter of the day. X equals negative 4. Guess what? You are? Done. Now equivalency. Some books, some answer in the book will move it to make sure it goes to 0. So I want to give you all different choices of equivalency of answer. Sometimes it will also solve for R. Shh. So keep in mind that these are all exactly the same. That's an egg roll.
Egg roll?
Because it's a wrap.